Okay, hi everyone. Sorry I'm not here today. I have training, uh, but I do want to start on molecular compounds. So I'm going to teach you about how we form molecular compounds and then how we name molecular compounds and come up with molecular formulas for molecular compounds. You're not going to be tested on how they form. It's just going to be about naming them, like going from a formula to a name and then a name back to a formula. That's what your quiz is going to be on Tuesday. But it's still important to know why molecular compounds are different from ionic compounds. So we're going to talk first about how they form and then kind of what they are, and then we'll get into the naming. Okay. So remember, an ionic compound. Oops, didn't want to go forward yet. An ionic compound was made up of metal and non-metal. Oh yeah, sorry. This is page. This is page 44. Okay, page 44 of your book if you don't already have it open. Okay, so it's metal and non-metal. Uh, they're two ions that make up the bond. That's why it's called an ionic compound. Okay, molecular compounds are going to be different. Okay, we're not going to have metal and non-metal. So there are two main types of compounds that can form. Ionic compounds that are a metal and a non-metal, like sodium chloride, and molecular compounds, which are a non-metal and another non-metal. Okay, we could have multiple non-metals, but we're just going to talk about two. Okay, so ionic is metal, non-metal. Molecular is two non-metals. Okay, so remember, metals are everything on the left side of the periodic table, left of that kind of staircase looking thing, which were metalloids. So everything on the left of that staircase are metals, everything on the right are non-metals. So we're only going to be dealing with a couple of elements here, okay, because there's fewer elements that are non-metals on the right side of the periodic table. Like CO2, can anyone tell me what that is? Good, whoever yelled out carbon dioxide. Good job. I really hope someone yelled that out, otherwise it would sound crazy right now. Okay, carbon dioxide. Okay, so carbon and oxygen are both nonmetals. That's why it's a molecular compound. Okay, so they're different in how they form, and they're different also in how we name them. Okay, whereas we had sodium chloride here, we name that differently than our molecular compounds. So molecular compounds again made up of two or more nonmetals. So properties of molecular compounds. Ionic compounds, remember, they are conductive. Uh, they are usually solids. Okay, and they form like crystalline structures. Okay, molecular compounds meanwhile have very low melting and boiling points. Okay, whereas ionic were very high melting boiling points. So molecular compounds can be solids, liquids, or gases at room temperature. Okay, like carbon dioxide is a gas at room temperature. Water is a liquid at room temperature. Okay, and then something that's solids would be like sugar. Sugar is different than table salt. Table salt's ionic compound. Sugar, like sucrose, is a uh, is a molecular compound, but it's a solid at room temperature. Okay, and they're also very poor conductors of electricity. Okay, pure water doesn't conduct electricity as well as salt water does because of the salt. So when atoms in the molecular compound combine, instead of passing the electron between each other, they share the electron. Okay, it's like I'm trying to teach my son right now. If he is playing with one of his trucks, okay, he's just playing with his truck. I'm sitting there beside him, watch him play with his truck. I pick up a ball, just start bouncing it out of just kind of a habit. I'm just like playing with the ball, throwing it back and forth between my hands. He's seeing me playing with the ball. He wants the ball. So he comes crawling over. He takes the ball from me. Okay. Of course, I try to be a nice dad. I give him the ball. Okay. So that would be an ionic compound. Okay. He is taking the ball from me and then playing with it. So that is him taking the electron from me. In a molecular compound, what we would do instead, we would share the ball, so we might pass it back and forth. He's only one. He doesn't really get it passing back and forth. He'll just throw it all over the room. So it's not a great example. But when he's a little older and we can throw the ball back and forth, that would be kind of sharing the electron. Okay. Sorry, kind of went off the rails with that analogy here. But the main point of my story is that the electrons are shared. Okay. So these form small groups called molecules. The type of bond that forms in the atoms of a molecule is called a covalent bond. Okay, so the sharing of electrons is a covalent bond. So molecular compounds create covalent bonds. Covalent bonds create molecular compounds. Ionic bonds create ionic compounds. Okay, because we're two ions here, it's called covalent because the electrons are shared. So we have what's called elementary hydrogen, just two hydrogen by itself. Elementary chlorine, chlorine just by itself. That's what that means. Here's our big one, water. So oxygen has 6 electrons here. Hydrogen has 1 each. They come together. Oxygen has 8. Both hydrogens have 2 that they need. Okay. And methane also. They share the electrons. Okay. So the electron counts towards both of their valence shells. Okay. So remember, ionic compounds, the metal gave its electrons to the nonmetal. So here the two nonmetals will share electrons. So if I have hydrogen, they each have 1 electron. In order to make a full valence shell, because it's the first shell, each hydrogen just needs 2 electrons in that valence shell. Okay? But they're not going to give the electron to each other. This hydrogen will give it to that one because then this one's going to have none. Okay? It's going to be a proton by itself. Doesn't want to do that. What they do instead is they come together and they share the electron. Okay? So now this atom has 2 electrons in its valence shell. And this atom has 2 electrons in its valence shell. Let's get one that's not spinning so that's easier to visualize. Okay, like water. Oxygen normally has 1, 2, 1, 2, 3, 4, 5, 6 valence electrons. Hydrogen only has 1. This hydrogen only has 1 valence electron. Okay, both of these hydrogens want 2 valence electrons. Oxygen wants 8 valence electrons because that's the second shell. Okay, so what they do, hydrogens come up and they share the electrons. So now we use blue for oxygen. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it has 8 electrons in its valence shell that it can count towards itself. Oxygen is now happy. Okay, but it's not an ion because it doesn't fully have those electrons. It has to share them. Hydrogen has 1, 2 electrons in its valence shell. Hydrogen's happy. This hydrogen has 1, 2 valence electrons. It's happy. Okay, so these are not ions because they haven't fully taken the electrons. They're just passing them back and forth. Okay, so the electrons might do a loop around oxygen, then they might do a loop around this hydrogen, go back to oxygen, and they'll do a loop around this one, and then skip this one, go back to oxygen, go to this one, then go right to this one. Okay, so they're not ions, they share the electrons. Okay, so the different ways we can draw them are kind of Bohr diagrams or Bohr-Rutherford diagrams, shows the electrons being shared. So remember, sharing electrons are molecular compounds, covalent bonds, or a ball and stick method. Okay, so if we were to create them 3D, if you take the 12U bioclass, we're going to build molecules with the ball and stick method. So it represents a covalent bond. So each stick here would be 1, 2 electrons. 1, 2 electrons. Okay. or the overlap method, which just shows how they're connected. Okay, so the electrons are kind of 1, 2 here, 1, 2 here that are shared. Okay, so if you want, I need to continue on to the naming note, but what you can do at the bottom of that chart is just do comparison. So what atoms are involved between ionic and molecular compounds, what is the name of the bonds, what happens to the electrons in the bonds, and then what about conductivity? Are they conductive? Conductive. That's not how you spell conductivity. The state that they're in, so the state of matter, or their melting boiling points. Okay, so let's move on now to what you will be tested on: names and formulas of molecular compounds. So remember, when we have 2 or more different nonmetals, we have a molecular compound. So there's no metals. Just do screen. No metals. I don't know if green will work. Oh, that's red. Look. I don't like how that looks. Green it is. Okay. So methane gas. Okay. Methane gas is one of our greenhouse gases, and a lot of it comes from the how can I put this delicately? The farts from cows. Okay, so we have large herds of cow that we use to create beef that we consume. Okay, but while the cows are being raised, they eat and they pass a lot of gas, and that gas is methane. Okay, so it's a short-lived greenhouse gas, lasts about 12 years in our atmosphere, 60% caused by human activity, which is our livestock primarily, but also mining, gas exploitation, and rice farming, oddly enough. Okay, so it's bad for human health and the air quality. But methane gas, the formula is CH4, carbon, and 4 hydrogen atoms, all non-metals. Okay, I think I forgot to mention this. Hydrogen is going to be the only non-metal on the left side of the table, but that's why like it kind of has its own box before you get down to the metals there on the periodic table, just to show that's different. Okay, so molecular compounds are named similarly to ionic compounds. So with the end, so how we had aluminum bromide for an ionic compound, the IDE, we use that suffix. Okay, so the end of the compound is going to have IDE. But we also use a prefix system for naming molecular compounds. And that kind of helps tell you that it's molecular compound, not an ionic compound. Okay, so based on how many atoms we have in the molecule, we're going to use a different prefix. So if I have 1 atom in the compound, it is mono. Okay, like carbon monoxide. If I have 2 atoms, the prefix is di, like carbon dioxide. Okay. 3, be tri, like a tricycle. 4 is tetra. Okay. Tetra in science means 4. Okay. 5, penta, like a pentagon. 6, hexa, like a hexagon. Okay. So mono is 1, di sounds similar to bi, but instead of bi being 2 for a bunch of other prefixes, like a binomial math, di is 2 in science for chemistry. Okay. Tri is 3, tetra 4, penta 5, hexa 6. Most of these are pretty self-explanatory. Tetra is the one weird one that you just have to remember. Okay. So when we name molecular compounds, check first to see if there's metal present in the formula. If there's no metal, then it's a molecular compound. Please tell me that I'm recording. Okay, good. almost lost my mind because I've been talking to myself for a while for no reason. Okay, so if there's no metal, we are molecular. Okay, so we write the name of the first element, including a prefix. Okay, so whichever element comes first in the chemical formula, you write that one first. Okay, so include the prefix. If there's only one atom, then you don't include the prefix. So if it's mono for the first atom, don't put the prefix. Okay, because again, like when we're doing chemical formulas, if there's just one of the atom, then it's assumed to be a one. Okay, if it's a second atom, then you do need to add the mono. Okay, so when you're writing the second element, include the prefix no matter what it is. It can be mono, like carbon monoxide. Okay, it's not monocarbon monoxide. Okay, so this indicates the number of atoms are present. And then change the ending of the second element to IDE again. So molecular compounds are a little bit trickier than ionic compounds, but you'll get the hang of it. So let's look at the first one. P. P, remember, is phosphor. Okay, and I have 2 phosphor atoms. And 2, the symbol, remember, is di. So diphosphorus. Now I have O is oxygen, and I have 5 oxygen atoms. And 5, like a pentagon, is penta. Do I have... Oops, sorry. So just some rules for vowels. If you have an A followed by the vowel, you get rid of the A. Okay, so here we're going to have pentoxide. If you have an O followed by another O, drop one of the O's. So you don't. So it's not pentaoxide, it's just pentoxide for that one. For this one, it's not monooxide, it's just monoxide. Rolls off the tongue easier. If you have an I followed by another I, oddly enough, you keep both. Because if you don't remember this, don't have an A with a vowel. Okay. So like we're Canadian, we say A a lot. Don't say A for chemistry. If you have an O followed by another O, don't have 2 O's. Don't go O, whoa, just O. Okay. If you have an I followed by another I, keep both of them because you have 2 I's. Okay. You have 2 I's, so keep them both. Let's go back. So diphosphorus pent oxide. So not pentaoxide, just pentoxide. C is carbon. The carbon, we only have 1 carbon, so I don't need to write the monocarbon. I just do carbon because it's the first element. Next is oxygen. I only have 1 oxygen, but because it's the second element, that's where I write the mono. And then I don't want to have monooxide because that sounds weird. So it's carbon monoxide. Next, cis2. Si is silicon. I only have 1 silicon atom, so it's just silicon. And then S is sulfur. I have 2 sulfurs. 2 prefix is di. Sulfide. So remember, change that ending to IDE. Okay, last one. My element here is carbon. And just one of them, so I have carbon. I have chlorine next, so that's going to become chloride, and I have 4 of them. So if you want, you can write it this way. We have chlorine. I'm going to change that to chloride. And then fill in how many elements I have. So my prefix was for 4. 4 prefix is tetra. Okay. So I have phosphorus, pentoxide, carbon monoxide, silicon disulfide, and carbon tetrafluoride. Sorry, that kind of got squished there. Let me rewrite that. tetrachloride. There we go. And they're written there nicely anyways. Okay, so remember, A in a vowel, drop the A. So do we want to say A? No, not A. Okay. O followed by another O, just one O. Okay. Okay. One O. Okay. I by another I. Keep both because you have two I's. You have two peepers. Okay. So that is how we make the names. The names are probably the hardest thing to do for naming of molecular compounds are probably the hardest thing to do of all the naming. Because naming ionic are easy, doing the ionic formulas are also easy. Okay. For molecular compounds, no crisscrossing. Okay. We're not taking any more steps from the cha-cha slide. Okay. I can hear your disappointment in the past from where I am right now. So do not use the crisscross. No crisscrossing. No. Okay. So what we want to do is check to see if there's a metal present. If there's no metal present, then we know that's molecular. We're good to go. So we write the symbol of the first element and then add the subscript to indicate the number of atoms. So we use the prefix to determine this. Okay. So this is even easier, I think, than the ionic compounds. Okay. Because we're not crisscrossing. We don't have to possibly reduce anything. We just look at the name and then it tells us exactly what element it is and how many of each element there are. Okay, so we start with the first element, write the symbol, use the prefix, write how many of them there are. Second one, write the second element, and then for your subscript, the little number, use the prefix again. Okay, it is super easy. So diphosphorus pentasulfide. Phosphorus, the symbol is capital P. Di, remember, means two. And sorry, phosphorus is P. So we have P2, pentasulfide. Sulfide is sulfur, so that's an S. P2S, penta, means 5. So P2S5. And that's it. See how easy it is? You look at the element, and then the prefix to tell you element symbol, prefix number. Element symbol, prefix number. Okay, so next one. Next, sulfur. Sulfur is easy. We just did it. It's an S. Now, there's no prefix here. So that means that the prefix should be mono because it's not there. So mono as a prefix is 1 for my for my subscript. But remember, if the subscript's 1, I don't have to put that. So it would just be S. Then fluoride is fluorine, so I put an F there. Tetra means 4. So it's SF4. Arsenic, tribromide. Okay. Arsenic, symbol, I believe is a R. And then there's no mono or there's no prefix. That means that's mono, which means there's just one arsenic. So it's just AR. Tribromide. Bromide is bromine, which is BR. Tri means 3. Okay. Last one, nitrogen dioxide. Nitrogen is 2. No prefix, so we just have one nitrogen. Dioxide, oxide is oxygen, so we have NO. 2 for the di. Okay. So naming molecular compounds is probably the hardest thing for naming, but then going from the name to the chemical formula is probably the easiest one. Okay, easier than anything from ionic. Okay, P2S5. Oh, sorry. Arsenic is AS, not AR. AR is argon. Whoops. Okay. So now for the rest of the day, you can work on your molecular compound worksheet. And then tomorrow you'll do a worksheet to determine whether something is ionic or covalent. And then I'll be back on Monday and we can review everything before your quiz on Monday. Or sorry, your quiz on Tuesday. I'll be back on Monday. All right. Have a good weekend.